Hello everyone, welcome back to logicbinder. In today's video, we shall learn few more examples of construction of DFA. Design a DFA which accepts the string 1100 as a substring over the input 0 and 1. Let us assume L of M is a language such that the string W of a language is in the form of X 1100Y. Here X is a prefix and Y is a suffix of a string. It means since 1100 is a substring, before this we can have any zeros and ones, after this we can have any number of zeros and ones, where x, y, w belongs to the input sigma. So the sample strings generated can be 01100, 11100, 0110010, so on. Upon generating a sample strings, we need to construct the minimal automata. In the minimal automata, we need to process the basic string. Here the basic string is a substring 1100. So from initial state Q0, we are sending 1100 to the state Q4. Upon generating the minimal automata, we have to give the remaining input transitions to make it as a DFA. Upon generating a DFA, we can write the transition table and transition functions. Consider this transition diagram. Here Q0 on 0 is moving to Q0. So in the transition table, with rows and columns as input and corresponding states, we are considering the states on each input. So Q0 on 0 is moving to Q0. Similarly, Q0 on 1 is moving to Q1. So Q0 on 1, the cell entry will be Q1. Q1 on 0 is Q0, Q1 on 1 is Q2. So Q1 on 0 is Q0, Q1 on 1 is Q2. In the same way, we have to generate all the entries in the transition table. And the transition functions can be written as Q0 on 0 is moving to Q0. So delta Q0 on 0 is equal to Q0. Q0 on 1 is moving to Q1. So delta Q0 on 1 is Q1. Q1 on 1 is moving to Q2. So delta Q1 on 1 is moving to Q2. Q1 on 0 is Q0. So delta Q1 on 0 is Q0. In the same way, we have to generate all the transition functions. One more example of a DFA is construction of a DFA which accepts 1100 only. We need to generate a DFA which should process only 1100. Other than this, no string should be processed by the DFA. So the minimal automata will generate the basic string. Q0 on reading 1 goes to Q1, on 1 goes to Q2, on 0 goes to Q3, on 0 goes to Q4. The basic string 1100 is processed through the minimal automata. Upon giving a remaining input transition for each state, we'll get the complete DFA. Here Q0 on 1 is already completed. So remaining input transition for Q0 state is Q0 on 0. Since 1 is the first input, it should not generate 0 as an input. Q0 upon reading 0 should be connected to the trap state Q5. Similarly, Q1 on 1 is already completed. Remaining input is Q1 on 0. It should be connected to the trap. Q2 on 0 is completed, remaining is Q2 on 1, should be connected to the trap. Q3 on 0 is completed, remaining input is Q3 on 1, it should connect to the trap. Upon completing 1100, final state should not accept any other input. So from this final state, if we read either 0 or 1, should be connected to the trap state. Thus, this is a complete DFA which is accepting only 1100. Any other input from the state should be connected to the trap state. Since it is a DFA, we have to define 0 and 1 transitions to the trap state which is Q5. So Q5 upon reading 0 and 1 is also connecting to the same trap state. Next, construct the DFA with exactly two A's over the input A and B. Let the language be AA, BAA, ABAB, BABA, BAABB, so on. In these strings, we have observed that we are having exactly two A's and any number of B's. The minimal automata will process two A's from the initial state. Upon giving a remaining input transitions to each state, we'll observe the DFA. So Q0 on A is already completed. Q0 on B can be connected to the same state because the DFA is having exactly two A's as a input. Before these two A's, we can have any number of B's. So Q0 on B can be connected to the same state. Similarly, Q1 on B can also be connected to the same state so that the string will be B, A, B, A. With Q2 as a final state, we have observed the string as B, A, any number of B, A. Two A's are processed. Similarly, Q2, which is a final state, should be given with the B and A transition. Q2 upon reading A will be connected to the trap. Since our language is containing only 2 A's, exactly 2 A's, third A should not be in the language. So Q2 upon reading the third A should be connected to the trap state, which is a Q3. Similarly, Q2 upon reading B can be connected to the same state, so that the string will be BA, BA, B. Any number of B's are accepted in a DFA, so that it will be connected to the same state. So this is a complete DFA. Based upon the transition diagram, we can generate the transition table. From the transition diagram of a DFA, we can generate the transition table. In the transition table, we are considering the set of states and input alphabet as rows and column. So here Q0 on A is moving to Q1. So Q0 on A is entered as Q1. Q0 on B is moving to Q0. So Q0 on B is entered as Q0. Similarly, Q1 on A is moving to Q2. Q1 on B is moving to Q1. So Q1 on A is Q2. Q1 on B is Q1. In the same way, we have to give all the entries in the transition table. Our example is construct a DFA with exactly one A over input A and B. Let us assume L of M is a language with the sample strings A, BA, ABB, BABB, so on. Here all the strings are having exactly one A. So the minimal automata will process single A from initial state to the final state. Upon giving a remaining input transition, we construct the complete DFA. So Q0 on A is already done. The remaining transition on a state Q0 is B transition. So Q0 on B can be connected to the same state, because from initial to final state, it should generate exactly one A. So before this A, we can have any number of B's. Similarly, Q1, we have to generate both A and B transitions. Q1 on A cannot be connected anywhere in this particular automata, because the DFA should process single A, so Q1 on one more A should be connected to trap. Similarly, Q1 on B can be connected to the same state, because the DFA is accepting the language of single A. Before this A or after this A, we can have any number of B's. So Q1 on B can be directly connected to the same state. Thus, since it is a DFA, in the DFA for each state we have to generate a input transition. So Q2, which is a trap state, should be defined with the input transitions. Q2 upon reading either A or B will be connected to the same trap state.